Good afternoon to everyone again. Today I will present you the HumAIne benchmarking suite, structured and reproducible way to evaluate human AI collaboration systems. This work is a part of work package 3 in a HumAIne project and focuses on moving from model-centric evaluation to collaboration-centric evaluation. In this webinar, we will cover the following sections: why collaboration benchmarking matters, the human AI collaboration evaluation framework, and how the architecture works in this work, and the core hike metrics. Also, at the end, we will cover some modules that we integrated in our platform, and finally, how this integrates into real pilots and real-life applications. So before I begin, let me begin with a simple observation that we have done, that AI systems are no longer isolated predictive models. They operate inside decision processes, and they suggest, they recommend, they prioritize, classify, but the human still remains in the loop. So, two AI systems can have identical accuracy and produce completely different collaboration dynamics. One may reduce decision time and increase trust. Another one may overload users, increase cognitive burden, and generate frequent overrides. These metrics evaluate the model, not the collaboration. This is the methodological gap that here we can address. We want to address with this benchmarking suite. So the question is, if AI now operates inside the collaboration, why do we still evaluate it as if it operates alone? Human AI systems introduce new dynamics: trust and override behavior, human effort, adaptation over time, system level efficiency. If we don't measure these, we are only measure half of the system, because we believe that the human is part of this system. So, starting describing the human AI collaboration evaluation framework that we have developed, we decompose the collaboration into three operational dimensions that are fully computable from logs: goals and efficiency, interaction dynamics, task allocation between human and AI. Crucially, these are not conceptually only. They are operationalized as computable metrics derived directly from the interaction logs. This is what makes the framework scalable and reproducible. The architecture is intentionally domain agnostic. Whether it's healthcare, energy, manufacturing, or smart cities application, the structure remains the same. A pilot or simulation emits logs from the interactions into a standardized logging schema, and the metrics engine computes the collaboration metrics, and the results are exposed via dashboards or APIs. This unified logging schema is the backbone. Every decision event, who acted, what action, how long it took, whether it was correct, is captured in a consistent structure. This enables the comparability across domains and, of course, within the same domain with different models. This is not an implementation detail. This is a structural contract that makes collaboration benchmarking possible. Without structured logging, structured benchmarking is impossible. So we define a minimal but expressive set of collaboration metrics. In the category of efficiency, the effort loss is relative to a relative gap between a baseline uh, mean duration, which is the average task time. The category of interaction is the frequency of interactions, which describes the interaction density. The human-centeredness, which is the cognitive load proxy. The collaboration category has the trust proxy, which is the acceptance rate from human, and the adaptability is improvement over time. And also one category, which is will be explained later, the simulation, which is the surrogate similarity, alignment of simulated and real behavior. Uh, These metrics are derived directly from interaction logs. So if we see an effort loss of 0.2, it means that the collaborative process is being 20% slower than the manual baseline, which is maybe for our system not good, but it's an indication that we have done something, uh, we have to act on this model or system. Trust proxy measures acceptance rate. Here you can see that this example is 92.5% acceptance rate of the human from the AI system. Adaptability captures the improvement over time, and here you can see 0.5 75 sorry, percent, which is a relative gain on the evolution. The point here is not the algebra. The point here is that these indicators are automatically derived from structured logs. And here is the interpretation of these metrics, which is more like algebra, but at the end of the day, we need decisions. So the decisions have to be made by these numbers. So we try to help the humans to decide if their system is good or bad. So with this quadrant, which it combines the efficiency and the trust metric, uh, we can see in the x-axis the efficiency relative to baseline and the y-axis the trust proxy. So if efficiency is high and trust is high, then we have the ideal collaboration. If efficiency is high but the trust is low, the AI may be effective but resisted by the human. If both are low, then we are sure that redesign is needed on this system. The key point is that collaboration quality is multidimensional. Efficiency alone is not enough. Trust alone also is not enough. So far, we discussed about the measurements and the evaluation framework as a theoretical uh, framework. Now we extend this into validation and the responsible deployment. A distinctive contribution of this suite is the simulation-based benchmarking. Even before pilot integration is complete, we can define environments, configure agents, run controlled experiments, and generate logs that are structurally identical to real-world data. This allows us early validation, reproducibility, and safe experimentation with alternative collaboration designs. And the core components of this simulation module, as we call it, is the environment builder, where we define task context. The surrogate agents simulate the human behavior, a unified logging identical to real-world schema, and the computation, of course, of the metrics, where we have instant results on our uh, export. Module number two is fairness, which is built into the suite. and we slice the results by group and compute accuracy by group, selection rates, demographic parity differences, equalized odds. Responsible AI requires a group of level auditing alongside collaboration metrics. We analyze these disparities with fair learn uh, style slices where accuracy, differential, the latency by group. The goal is not just more accurate, but more equitable. Technical performance alone is not sufficient. So we have integrated into this platform the system usability scale, where we provide to our partners who use this benchmarking suite the ability, the feature that they can provide to their users a questionnaire from a system usability scale in order to answer and evaluate uh, the the friendliness of their system in terms of fairness, transparency, and trust perception. These scores are linked directly to run IDs and model versions, enabling traceable evaluations. We extend this system usability scale questionnaire with questions that maybe the partners want uh, to add on their on this questionnaire, and uh, they can ask whatever they want beyond the standard questionnaire. So, from a developer perspective, integration requires 4 steps and no domain-specific benchmarking logic required. To integrate, we have first to define environment and agents. Agents could be humans and AI, of course, a system. Then emit logs via REST APIs or MinIO as we use in HumAIne, or upload directly to the platform through our user interface or the common interface, common front end from the HumAIne OS system. So no domain-specific logic is required in this benchmarking layer, and then the evaluation triggered, and the platform handles the rest, and then we can access to a dashboard, or we can get the results of this metric engine through an API and make comparisons across our models. So, applications. Talking to all of this theoretical development uh, is fine, but in the design and the perspective of a theoretical discussion, but we have to validate and check how it works, and we have to see them on the field. So we have first I will show you a scenario, a healthcare use case, which is our demo use case, where we can see 2 roles: AI classifier, which is a type agent, artificial agent, and of course a human radiologist who reviews and accepts or overrides the proposed disease prediction from the system. So our objective here is, of course, to measure the collaboration quality across diagnostic session of this uh, system and these 2 participants. So in action, on the left, you see the process in steps, and we highlight the upload, review, and annotation steps, where the radiologist takes the proposal of the AI system, and if he or she doesn't accept, it proposes a new area with a bounded box and saves the cap and we capture the image and the AI output. So this produces the decision, as we see earlier, the decision logs, and which are consumed by the benchmarking suite. This UI captures exactly what we need for metrics and retraining by design. Then the results are uh, computed and presented to the user as long as the logs are uploaded on the benchmarking suite on the platform. And our interaction lens focuses on how work happens, not just accuracy of the model. F is the interactions per minute, how active the collaboration is. D, duration, action duration, where the time is spent. Human cognitive load proxy, HSL, it means that if we have low response times, mean higher human cognitive load. Trust proxy, which means fewer errors and overrides is good. Uh, the human trust the system. Uh, Adaptability, A, measures adaptation between early and late phases. And of course, S, the simulation similarity to surrogate agent uh, is a metric that we use it especially when we don't use real world data, but the simulation module. So we quantify the collaboration quality, human load, trust, adaptation, and efficiency alongside the accuracy of the system. But we don't forget that the AI system is not only uh, human AI collaboration. And of course, if the logs are provided to the benchmarking suite, we can, of course, track the metrics, the traditional metrics of an AI model. So beyond the core human AI collaboration interaction metrics, we track outcome-oriented signals that product teams ask for. Correction efficiency shows how quickly issues are fixed once surfaced. Error reduction rate tracks whether the successive iterations actually drive mistakes down. And knowledge retention captures whether users retain skill when the AI is present. And of course, the response time. All these come from the same logs if they're provided. Now, sorry, uh, now I will show you a quick demo through a video. How easy is the process for a user to upload and trigger the evaluation, and how the benchmarking suite platform works. I will narrate and I will go through the video live. So here you see the homepage of the benchmarking platform, but sorry, sorry about this. And I'm showing as a test case the use case, the healthcare radiologist paradigm I showed you in the slides here, where a radiologist have the AI system proposal, and he or she rejects and suggests a new decision, a new bounding works. All these uh, actions and interactions are logged to the back end of the system. It's outside, of course, benchmarking suite. All this happens to the pilot that uses, and all these are logged to JSON files, and then someone can upload all these logs either from the benchmarking platform, the UI here, and under one configuration file, and give some uh, short description of the task, and upload here the log file that produced in their system. Of course, then here you can see that running a triggers evaluation and then present search for the results, uh, which can be presented in terms of its model version, what happened exactly, what are the metrics in its model version, or the aggregated ones. Here, where the charts are presented and the x-axis shows the model version of the AI system, and the value is in y-axis. All the metrics are presented in categories, groups, as I showed you earlier. And from here, the users can take insights for their system, and the collaboration between human and their system, of course. That's it. And of course, we have uh, the human AI collaboration metrics and the formulas that all these are computed in order to have transparency in our work. So, of course, we're happy that within HumAIne project, we had the first real-world validation of the platform, and the insights of these metrics showed to the partner useful and meaningful, which came from the Smart Cities pilot from partner Novoville, and the context was an AI-assisted parking permit approval sessions. So we processed 566 real municipal applications using operational data exported the MinIO, and the standardized JSON logging that I showed you earlier. These logs were ingested into benchmarking suite, where the collaboration metrics were computed automatically. The goal was not only to improve efficiency, but to quantify the collaboration quality in real deployment scenario between two models of our partner. So, comparing these two different AI model versions, our partner and we, of course, observed a 60% reduction in average action time, which is substantial operational gain for their system. And interaction frequency increased moderately, but suggesting more active collaboration. Trust proxy improved by 10%, indicating higher acceptance of AI suggestions. And importantly, the human centeredness indicator remained stable, meaning that efficiency gains didn't come from at the expense of cognitive overload of the human. So it's good insights, and the partner was happy that they saw that their improvement of the model was useful for the humans that they used this system. And of course, we are happy that we validate our initial design. So beyond the platform integration and the development, we are also packaging the logging schema and the HumAIne human AI collaboration metrics that we have defined, and as a Python library, open source, so teams can benchmark collaboration already at design time. You can find it through GitHub. It's an initial try, but we are developing and enhancing and a lot. So let me conclude with 5 key points. Collaboration, we saw that the collaboration must be benchmarked, not only the model performance. Structured logs enable structured metrics, of course. Simulation allows safe early validation to the systems and the developers and the decision makers of the systems. Fairness and usability are degraded by design in our system, in our framework generally. And the platform tries to be domain agnostic and reusable. Either it has sometimes it has it's difficult to have this, but we try. In short, we now have an operational way to measure the human AI collaboration, and this is what I presented to you this afternoon. So thank you for your attention.